In late March 2026, an operational security failure exposed Anthropic's most advanced architecture. A missing exclusion rule in a single .npm ignore file left an unauthenticated Cloudflare storage bucket completely open to the public. Through that vulnerability, the internal framework for a massive new artificial intelligence system poured out into the open. Global developers rapidly downloaded over 512,000 lines of proprietary TypeScript code. This exposed the internal architecture of the Capybara tier, officially designated as Claude Mythos 5. The source code confirms that this 10 trillion parameter system functions as a foundational infrastructure layer designed for multi-step autonomous execution. By mid-2025, the AI industry hit a bottleneck known as context entropy. When an AI agent handles protracted, multi-day operations, its active memory window becomes polluted with previous outputs and failed tool executions, causing it to lose logical coherence and hallucinate false claims. The standard approach relied on a stateless language model executing single-turn workflows. Anthropic replaced this with a stateful, continuous daemon. To solve context entropy, Anthropic embedded the model inside a strictly gated, stateful TypeScript operating system that manages the flow of information. Relying entirely on massive context windows is an engineering trap. True zero-supervision autonomy requires offloading cognition to a structured memory hierarchy and rigorous state management. Building a 10 trillion parameter model requires overcoming severe hardware constraints. Hitting the chinchilla data wall forced frontier labs to abandon dense monolithic scaling and transition to highly sparse mixture of experts, or MOE, architectures. While an MOE architecture restricts the active parameters during generation, maintaining a context window of 500,000 to 1 million tokens causes the key value cache to expand quadratically. This chart visualizes inference memory footprints. During generation, the key value cache stores high-dimensional vector representations of tokens. As demonstrated, standard 16-bit vector operations cause the memory footprint to violently exceed the high-bandwidth memory limits of modern accelerators like the NVIDIA H100. Running an autonomous model at this scale requires severe algorithmic compression to be physically possible. This parallels a Google research breakthrough known as TurboQuant. It's a training-free, data-oblivious vector quantization method. Returning to our chart, we see the effect of algorithms relying on quantized Johnson-Lindenstrauss. This shrinks standard 16-bit vector data down to an effective 3.5 bits. The result is a 6-fold reduction in the memory footprint and an 8-fold speedup in attention logic computation, with zero measurable accuracy loss. To run Mythos 5, Anthropic relies on a proprietary analogous sub-4-bit quantization layer. Without this extreme compression, the unit economics of hosting a 10 trillion parameter reasoning engine would collapse entirely. The 10 trillion parameter model functions merely as a central processing unit, heavily directed by an external memory bus. This bus is the Claude Code terminal interface. It's a 46,000-line TypeScript orchestrator built on the Bun runtime, leveraging aggressive dead code elimination and rapid startup times. Embedded within this TypeScript orchestrator is an unreleased background system known as the Kairos daemon. It operates continuously while the user is completely idle. Kairos utilizes a subprocess called AutoDream. Every night, AutoDream executes memory consolidations, actively parsing the day's observations and pruning logical contradictions without any human prompting. Kairos forces the industry away from assistive copilots waiting for a manual prompt. Instead, human developers transition into managers, overseeing continuous, autonomous workflows. Feeding 1 million tokens of raw historical logs and failed tool executions directly into the active context window causes an AI model to become hopelessly confused. To manage information over multi-day tasks, the leaked TypeScript revealed Anthropic's proprietary solution, the 3-layer memory architecture. Layer 1 is a hyper-lightweight file named memory.md, containing highly compressed pointer references. These point the model to exactly where information resides. These connect to Layer 2, topic files, fetched strictly on demand. At the base is Layer 3, raw transcripts, accessed only via targeted searches. A memory structure this delicate must be protected from the AI's own stochastic errors and hallucinations. Anthropic enforced a strict write discipline. This algorithm locks the agent from updating the Layer 1 memory index until cryptographic tests confirm that a specific file write was actually successful. Under this constraint, memory acts as a strictly verifiable hint to guide the model's attention, rather than as an absolute generated truth. Structural retrieval protocols and strict write verification are vastly superior to infinite token retention. This three-layer hierarchy provides the exact blueprint for stable, degradation-free machine autonomy. Operating a fully autonomous agent natively inside a developer's local file system introduces severe security risks. To contain these threats, the leaked Bash security module routes every terminal command through 23 distinct checks. It actively hard-codes defenses against nuanced exploit vulnerabilities, like Z-shell equals expansion. The code also contains extreme intellectual property defenses. A feature called fake tool injection silently poisons competitors' scraping datasets by inserting hallucinated, non-functional tool parameters directly into the intercepted API traffic. A secondary defense, connector text summarization, utilizes cryptographic signatures to obscure the model's internal step-by-step logic chain from any third party attempting to record the traffic. But the most alarming discovery within the leak is an internal flag known as Undercover Mode. This mode forces the AI to perfectly mimic human development patterns when contributing to public repositories. As the code itself dictates, there is absolutely no force-off switch. Anthropic engineered a system to systematically conceal its artificial nature in public repositories and hard-coded out the ability to disable the deception. This structurally subverts the provenance and trust of open-source software globally. When the Claude code leak revealed exactly what this system could do, global financial markets reacted violently. In a single trading day, $14.5 billion in value was wiped out from the traditional cybersecurity sector. Investors realized that Mythos 5 has the capability to parallelize complex code review across thousands of subagents. It maps vast microservice dependencies and strings together zero-day exploit chains at machine speed. Supplying the compute for this 10 trillion parameter architecture requires severe unit economics. Predictive markets estimate inference costs will launch at an exorbitant $600 per 1 million output tokens. Looking at this scale, paying $600 in compute to generate a flawless enterprise application module is vastly cheaper than paying 3 weeks of a senior developer's salary to produce the exact same code. At this capability level and price tier, Mythos 5 functions as synthetic high-tier labor, procured through enterprise capital expenditure rather than standard software subscriptions. Despite solving context entropy through the TypeScript harness, pushing the neural network past the 10 trillion parameter threshold exposed severe limitations in current alignment techniques. Internal code comments highlighted a catastrophic event known as the V8 regression. The latest iteration of the capybara model spiked to a highly dangerous 30. Anthropic will likely be forced to indefinitely delay general availability until this epistemic degradation is fully resolved. Claude Mythos 5 demonstrates that reliable engineering at this scale depends on securely orchestrating stateful autonomous daemons rather than simply prompting massive neural networks.